Welcome back, grade 12s. This video continues the problems where we are going to apply the principle of conservation of momentum as well as elastic versus inelastic collisions. This is video 2. Thank you for joining. Video 2 discusses my third example. It says a car mass 1,000 kilograms moves at 30 meters per second and collides head-on with a car mass 2,000 kilograms. The head-on collision means that the one car is coming from the front, so the two vehicles will be moving in opposite directions. Both cars comes to a standstill just after the collision. Calculate the initial velocity of the second car. Them coming to a standstill after the collision means that the total final momentum will be 0 kilograms meters per second. We're working with the principle of conservation of momentum, so the total initial momentum will be equal to the total final momentum. In order to calculate the initial momentum, car 1, mass 1, initial velocity 1, plus car 2 with its mass 2, initial velocity 2, that should equal 0. Now, if car 1 was moving to the right, then car B would be moving towards it. We have two vector quantities, and we need to decide which one we're going to take as our positive direction. I would take car 1's direction as positive, then car 2's direction would be negative. Here we go with our substitution. 1,000 kilograms times 30 plus 2,000 times VI2. That all adds up to 0. Our second car's initial velocity works out to be negative 15 meters per second. The meaning of the negative means that it's coming towards car 1. It's traveling in the opposite direction to car 1. After calculating the value, finding its negative, we need to say the car 2's initial velocity of 2 is 15 meters per second in the opposite direction to car 1's motion. Or we could say towards 1. Right. The next question is question 4. A bullet mass 0.25 grams leaves the barrel of a gun at 320 meters per second. Determine the recoil velocity of the gun. Now, the bullet and the gun was initially in a stationary state, so the initial momentum is 0 kilograms meters per second, stationary. Once the shot is fired, the gun recoils, pushes back, moves back, kicks back, while the bullet moves forward. So it's the mass of the gun times its final velocity plus the mass of the bullet and its final velocity. A bullet, the mass of the gun is 6 kilograms. Oops, I don't need to write the 6 there. Times 320. Mass of the bullet is 0.25 grams. So it's 0.00025. And its final velocity we don't know. Final velocity of the bullet will be negative 6 times 320 divided by 0.00025. That brings us to a ridiculous number. $7,680,000. This is hopelessly too much. I need to check my mistake here. Maybe the bullet's mass is too small. With the values that we've got here, 0.25 grams is 0.25 times 10 to the minus 3 kilograms. So I haven't made a mistake here. I have made a mistake in taking the velocity of the gun as 300. That's the mistake. All right. That will work out now. Sorry for my mistake. This is the gun's final velocity that we don't know. The bullet's velocity is 320. So the velocity of the gun after the fire was shot, the shot was fired, it is 0.00025 times 320. Divide that by 6 and we get a more realistic answer here, 0.013 meters per second. So it's negative 0.013 meters per second. So it's the recoil velocity is 0.013 meters per second. Sorry for confusing you there with my mistake. Thank you for watching the video. We'll continue more problem discussion in the next video.